Hi there, this video is about a new device I've been investigating called the OpenLog. Now this is essentially an Arduino based device, and we've seen some other Arduinos in earlier videos. So here's the Uno, which is probably the best well known. There's a miniaturized version of that called the Nano. There's the Mega 2560 over here, which is an expanded version of the Uno with more inputs and outputs. And a miniaturized version of the Mega, this unbranded one here. So we can see the OpenLog is a lot smaller. If I just put my finger by it, you can see just how small it is. And it's basically got the same AT Mega 328P chip on it as the Arduino Nano. So it's electrically equivalent to the Uno and the Nano. The only other components it's got on there are some resistors, capacitors, a crystal and a voltage regulator. But as we can see here on the other side of the board, there's a micro SD card slot. Also, unlike all these that typically come pre-programmed with what they call the blink sketch, which just flashes an LED on and off for test purposes, the OpenLog comes pre-programmed as a data logger from the serial port interface over here, the transmit and receive, to the SD card on the other side. And that's pretty fortunate really, because the only way of reprogramming the OpenLog, unlike all the other devices which have USB ports on them, this has got an SPI interface here which you'd have to wire up to something to provide a way of reprogramming it. So when might you use an OpenLog? Well, typically when you have a device such as this light meter here, which displays its output on the screen, and the only other output you've got on here is an RS232 connection, and that's on a jack plug which I've wired up to a standard 9-pin D connector. Now this just outputs its reading all the time on the RS232, so that can be logged on the OpenLog. Note, if you had a device that you had to poll for data by sending it a command, you couldn't do this with the OpenLog unless you specifically put a new program on it to poll for the data. Other devices we might want to log, well, we've got some multi-channel loggers here, data takers. The latest, these are pretty good loggers, and the latest version of course has a USB slot, so you can log directly to a USB memory stick. But these older versions, this one's from the late 1980s, that's from the early 2000s, don't have this. The main problem with them, they're very good for logging still, but the main limitation is the memory storage, which reflects the age of the devices. So this DT100 logger, for example, comes with either 16 or 24 kilobytes of random access memory, which you can log to. Since it's got up to 48 analog input channels and 8 digital inputs and outputs, obviously you're going to fill that memory up pretty quickly. I'm just trying to get the lid off this as I'm talking. So it might be alright if you want to log something every hour or every day on several channels, but if you're going to log every few seconds, then you're very quickly going to fill that 24 kilobytes of memory up. Therefore, we really want to have a way of expanding the memory on that logger. Now this is actually my preferred out of the two models, because it's actually got 48 independent analog inputs on these 6 analog to digital conversion chips here, and these are socketed so you can replace them if you happen to fry them. And this whole thing's using a technique called wire wrapping, which you see me use quite a lot on my Arduino projects, and this allows you very easily to change the connections that go to these generic sockets on the back. You've got RS232 input and output, which are essentially connected in parallel to each other and allow you to daisy chain between loggers, so you can have a network of several loggers. but these other 4 connectors are wired to the wire wrapping, and you custom wire them to your own needs. Another problem, as well as the very small memory storage, is the fact that it's volatile memory. So if your external power is lost and the internal NiCad batteries become depleted, you lose all your data. How about the DT505? Well, a much more modern device. Again, communications is via an RS232 port there. And this appears to have 20 analog inputs, or 10 if you're using them as differential inputs, and 4 digital input outputs. And I think these are some additional counter inputs. So the channel count's much lower than the DT100. And also you've only really got one analog input, and then it's got a relay multiplex inside to switch between them when it's logging. So it makes a horrendous clicking noise all the time and limits the maximum speed in which you can log. We had a rep in from this company probably about 10 to 15 years ago now. He was so impressed with the old DT100s. It's sort of legendary, this logger, because it's better than anything they produce now in many ways. So what does this DT505 log to? Well, it logs to these SRAM cards, and I think it supports cards of up to 4 megabytes. Again, by modern standards, minute. When you think modern logger, you could plug a massive USB stick of several gigabytes into it. Another issue with these cards is that it's again volatile memory, and it's got one of these coin cells inside. So if that goes flat, you lose all your data. And the card just sits in there. Again, the OpenLog can be used to log, both these loggers I should say, can be programmed to, as well as or instead of logging the data internally, they can return the data in real time via the RS232 port, which of course you can then log using your OpenLog. The other thing I should mention while I'm talking about the hardware is you'll see that I've got various things connected to my OpenLog here. That's just, and this was just for test purposes, this is a very early stage of development. You've got a power connector which you can provide with 5 volts of power. You've got the standard 9-pin D serial port. You've got a switch there, that's necessary to change the pin out of the serial connector, because although these devices use the standard pin out for going directly to a PC, the data takers use their own bespoke pin out. And then finally, this is very important to mention, we've got a Max 232 chip here in a pre-assembled package, and on the back of that you've got a few resistors and capacitors which are necessary for it to work. And this is a level converter between RS232, which can be up to 12 volts, and TTL transistor logic levels, which is what the OpenLog's transmit and receive lines work at. So if you didn't include that, you'd soon blow up your OpenLog. The OpenLog is configured, the easiest way to configure it is via a config file which you put on the SD card. And if there isn't a config file present, it will write the current settings to that config file. You can also operate it in command mode. Either you can set it up on the config file to start in command mode, or you can send a predefined, in which you set in the config file, series of ASCII codes to it. What they call the escape sequence. You set the character and the number of times it has to be received, and that will make it drop into command mode. And in command mode you can change the settings directly, and you can also interrogate the SD card in limited ways, such as you can bring up a file list, and you can find out the specifications of the SD card as well. I'll show you that on the computer in a minute. Before I finish this part of the video, this is just my wiring diagram for how I've implemented the wiring. So here you've got the transmit and receive side of the OpenLog. Here you've got the pins which are used for programming it, which I haven't investigated. Here you've got your power source, you've got your Max 232, and then I've got my 9-pin D connector with my double pole switch. And this is just the pin out of the RS232 for the two different types of device. Now I'll finish this video off just by going over to the computer and showing you some data I've logged and also the device operating in command mode. Okay, so I've got my OpenLog connected up to the PC now. I'm actually using a laptop which doesn't have a serial port, so I've got this cheapo USB docking connector which I use to connect my printer and things, and it's got a serial adapter on it, so I'm using that. This wire here is to go from the male serial connector on there to the male connector I've got on here, which would normally connect to my RS232 device, and I need to swap the transmit and receive lines, so that's what I've got on this adapter here. The ground's wired straight through. I powered this on with forgetting to put an SD card on it, and the yellow LED is indicating that it hasn't got an SD card that it can read by flashing 3 times every so often. I've now inserted an SD card, and I'm just going to show you what happens when I reapply power. I can do this one-handed, which is always difficult. You'll see a few LED flashes of both the green and the orange LED. The orange LED is sometimes blue on some models. Sorry, I'm having problems with the power connection here. I hate things when they do that. On my computer I'm running this serial terminal program called Serial Monitor Deluxe, and this is particularly useful as it lets you send any ASCII character. Now if I send something to it, like test test test, then I need a character return at the end, which is ASCII character 13, which I put in backslashes like that to send a ASCII 13. When I send that to the OpenLog, you should see some lights flash on it. The LED is in normal operation when it's not doing that error flashing when you turn it on. The orange or blue indicator mean that data is being received at the serial port, and the green LED means that it's writing to the SD card. Another thing we can do in our serial port is send what we call the escape sequence to it, which I've got set as 3 ASCII 26 characters, and you'll see then that the device responds by sending back this prompt. At this point I can send it question mark carriage return, and then it will reply with a list of commands I can issue. So for example, if I send it ls /13, that will give me a list of what files are on the SD card. ls is the sort of Unix command that's equivalent to dir in DOS. We can also get it to tell me about what the SD card is, so I can send it disk /13 /, and then it will give me some basic information on how big the SD card is. What else can I do? I can also change the baud rate by sending it baud. And then it will say, what do you want the new baud rate to be, or you can press X if you don't want to set it. So say I set it to 1200. So it's going to 1200 BPS, but you have to reboot the OpenLog for that to take effect. So it's now doing this orange flash of 5 orange flashes followed by a gap, and that basically means you need to reboot me to instigate the new baud rate. Now we'll just have a look at some of these files that are on the SD card. So the config.txt is what configures it, and the log files are the files of log data. These other files, the photo video folders and the time.txt, are to do with the spy camera pen, which I'll review in another video. So looking at this config file first, we can see the parameters in there. 1200 baud, which we just told it to change to. Escape character 26, that's ASCII 26, and it needs 3 of them to be put into command mode. If you set the escape number of escape characters 0, that basically disables that function, which could be useful if you were expecting a load of incoming binary data and it might accidentally include that. Then we've got something called mode, that's 0 if you want it to start off in logging mode where it logs to a new file on each power up. 1 if you want logging mode where it appends to the current file, and 2 if you want to start it in command mode. You've got a verbose message option, which you can set to 1 or 0. Echoes anything incoming back to the host. And ignore RX is to do with an option where you can tie the receive line low to force it into a known config when you start up. And again, that might be something that you don't want in your device, so you can change that to 1 to turn it off. Then if we look at one of the logged files, so this log 06 will be the one from what I was just doing, the test in that one. If I look in one of the earlier ones, I'm just trying to remember which one it might be. Yeah, so this is the data which was logged from the light meter when I was playing with it yesterday. And basically it's frames of 15 characters it returns, and it keeps sort of sending it back every second or so. I haven't timed how often it sends back, but it's something like every second. It sends this frame of characters. The unprintable character delimits a new set of data, and then the ASCII characters tell you what units it's set to use, like lux or foot candles, the polarity of the reading, what type of light source it's set to monitor, and the reading itself. So here we have the file opened in Excel, and I thought the strange non-printing character scan delimiter was going to be a problem. And if I just opened it from Windows Explorer, it did indeed all come out with the data in one cell on the first line. If I use the text import wizard, although it seems that you can't put in your own non-printing delimiters in there, it seems to just break the data up anyway into one reading per line, so that's fine. You'll see this shorter value on the first line is obviously where it started capturing the data part way through a transmission, so that's why that's shorter. All the others follow the same sort of format of this 15 character ASCII string. And then by using pretty simple Excel formulae, I can decode that. So there's an ASCII character there which tells you the polarity of each of the two readings, what units the data are in, how many decimal places the data's got, what the upper and lower display are. On the anemometer, which I haven't got any data for on the screen, the upper display is the wind speed and the lower display is the temperature. For the lux meter, the lower display is used to tell you what sort of light source it is, which I've got decoded over here using this multiple if statement. And then these other 3 characters are either question marks if they aren't used, or denote zeros for multipliers for the reading. So it's like a wraparound of the main reading of either multiplied by nothing, by 10 or by 100. And then we can just copy those formulae down and it'll come out with our light meter reading for each row. Okay, so I hadn't actually tested this before I started to make the video, which was a mistake because it all turned out to be a bit more involved than I thought. The serial port, particularly on this old logger, is even more non-standard than I thought, in that it needs a link across pins 5 and 7 to provide power to the from an internal power supply in the logger to the RS232 interface, and also ground isn't on the normal pin 5, it's on pin 1 and 2. So we're now sorted and we've got rid of the switch and just wired straight into there. And so I'm using the old data logger, which is probably what I forgot about when I made the switchy thing up, that this one was different again. And I'm using the old one because it's got two serial ports, which are just, well, that is actually one serial port on two identical sockets. So I can have the computer and the OpenLog connected at the same time. So I can send commands from the computer to the thing, which will get logged on the OpenLog, as well as any data that the OpenLog is outputting, the logger is outputting. The other reason I'm using the old one is I'm more familiar with its command set, which is command syntax, which is slightly different from the newer logger. So I'm just going to show you, I'm going to send it some commands and show you what happens on the OpenLog. So the first thing I'm going to do is reset the data logger by sending it reset. I'm then going to send it P22 equals 44. And what that does is makes the data delimiter a comma rather than its default of something like a tab, I think. I'm then going to send it a status command. No, I won't do that actually. Yes, I will. Type one-handed. Okay, and that returns what the data logger is doing at the moment. Then I'm going to send it a command to make it log something. So this is what I say. I've done caps lock on, I don't need it. R10S, that means report every 10 seconds. Oh, it's filled it in for me because I've already typed it. For report 10 seconds, the date and time, 25 MA, that's channel 25, which is some sort of temperature sensor. That's just a temperature sensor inside the logger itself. The /u means don't return units text, don't return channel numbers, don't echo data. And R means return data in real time, L means log to internal memory. And I've forgotten to set the clock, so I'll do that first. So I say D equals 0 because, am I on caps lock or not? I'm not sure. D equals 0 because this one doesn't store an actual date, it just stores a sequential date number. T equals whatever the time is, 11:28:00. And then my, God, the caps lock's gone off, has it? I don't know. R10, right, there we go. Send it that and that should start it logging. So after 10 seconds we should see a temperature come back, date, time and temperature. There we go. So that's telling me it's day number 0, it's 11:28 and it's 25 degrees C. And they'll come back every 10 seconds. Now if we move over here we should see lights flash on the OpenLog every 10 seconds as it receives data. At the same time that the little red light is flashing on the data logger here somewhere. You should see it flash in a second. There it goes. So when that flashes, the OpenLog flashes at the same time, so it's receiving data, which it's recording to the SD card. Finally, I'll just plug the SD card into the computer and we can see what it's logged. I should just have mentioned that because I've got the computer and the OpenLogger connected basically in parallel to the data logger at once, I deliberately haven't made the transmit connection from the OpenLog to the logger because it's never going to be used anyway and it could confuse it with the what's happening with the computer. So I've got the log file opened here. We can see down the bottom here these 10-second readings which have been logged, and we can also see it's logged all the other commands I sent from the computer. And this is quite handy. Before we had the OpenLog, I used to use something called a gigalog, which is a French cheapy data logger, which is also one of the things it can do is log from RS232, and that allows you to basically pass through commands from the computer to the RS232 port on the logger. This arrangement allows me to achieve a similar thing, and it's really handy in your file to have this status command as a sort of header, so you know what it's doing, especially if I'd have sent the status after I'd have started logging. Am I still connected to it? Can't remember what I'm doing now. Right, so I should be connected again. Should see some data coming in. Yeah, if I'd have sent the status after I'd have started the logging, it reports what the command is, which obviously is fairly trivial here, but if you've got lots of channels being logged, it could be quite handy to know what order things are in as a sort of header. Yeah, and this command set for the datalogger is also quite interesting in that it usually ignores everything in lowercase apart from these switch commands. So it means you can sort of self-document the commands. So I could have put report 10 seconds there with the import and econds in lowercase, and it would have worked. Yeah, so there's the OpenLog for you. The other thing I should mention is that I've got 3 of them, and one of them doesn't seem to be working properly. It can write a config file to the card if there's none on it, but it doesn't seem to do much else. And also this one, after I'd incorrectly wired it to the logger, which probably meant it had 9 volts going in on the ground wire, it stopped working until I'd fiddled around with it a bit. And they do seem to be quite sensitive to abuse like that, in that they go partially or fully corrupt, and you have to just fiddle around with them, sending them data from a computer and trying to reset them in various ways until they come back to life again. Thanks for watching.